Hello friends, this is Rishabh and I welcome you to this video on data containers and Python. Now what are data containers? Well, a lot of times primitive objects are not sufficient to represent all the data. So primitives like the integer or numeric values, then the float values, string values or the boolean values, they're not sufficient. What are the examples of such data? So for example, let's say I want to represent a series of first and natural numbers. How will I do that? Let's say if I have to represent a series of first 1 lakh natural numbers, it will require me to initialize 1 lakh variables to do that, and that is going to be very difficult for me to do manually. Then similarly, let's say I want to represent sensor data for 24 hours with a period of 1 hour, which means I want to represent some 24 entries. Then stock prices for 30 days and similarly marks of all the students of a class. So I have listed only 4 very basic examples, but there are so many examples in the real world where we have to represent a sequence of data and primitive values are not sufficient for that. So all the programming languages, they provide us with certain constructs, certain data containers which we can use to store such values. Like we can store sequence of the data types, sequence of data basically, in those data containers, right? Now talking about data containers in Python, well, first I think we have already discussed this, like the data containers. Okay, so one of the very basic data container is where we store the elements together in a sequence, as we discussed. And in Python this is called a list. Maybe I can highlight. So this is a list in Python. Now how exactly do we initialize a list in Python? As we saw that if we had to initialize a variable, let me just quickly jump to my Python interpreter. If I had to initialize some very basic value, let's say is equal to 21, this is how I used to do it. Now similarly for a list, we have to store all the values inside of a square bracket, and they have to be separated by commas. Or I can also initialize my list in this fashion, where I say list name is equal to list and enclosing list with brackets, because it's a function. I can initialize in both the ways. So here list name is the variable name which refers to the list, and then the empty square brackets, they represent an empty list. I can add values to that specific empty list. So let me just try to initialize a list here. Let me call it natural numbers only. Natural numbers equals this. This is one of the ways of initializing the list. Then I can also do natural numbers equals list. This is also one of the ways to initialize the list. Or what I can do is I can also do natural numbers equals 1 2 3 4 5. That is I can give some initial values to the list as well. So these are the different ways in which I can initialize the list. Now let's look at some examples. So for example, natural numbers we already saw that we can provide in this fashion. Similarly, if I had to represent days, I can do the way shown in this on this line number. Then similarly, whether there are let's say there are lamps, I want to store in a list whether they are on or off, then I can use booleans stating true could mean on and false could mean off. So in this fashion, list is very powerful data structure, and in a lot of complex programs we will see that a list can be used, and there are so many problems in data structures and algorithms which can be solved with the help of lists, because this is one of the most asked data structure in the interviews as well. Now there are times when we want to provide certain operations, when we want to perform certain operations on the lists, like adding all the elements, for example. How exactly are we going to do that? Let's take an example of that. Let me create a new file, call it add elements, and let's say that I have a list n, where n is my list of natural numbers. Let's say first 10 natural numbers, right? Now I want to add, and sum of list equals, it's currently 0. What I will do, I will use a for loop. So for I in range, let's say, now we have already started exploring the function. Now len is a function which returns me the length of the list. We can quickly verify this on my interpreter. So let's say n is a list of first 10 natural numbers. Now if I do length n, I get 10. So which means that this len basically returns me the length of the list. I'm providing this to a range function, so which will be creating a range object with a starting range and an ending range. So it's basically an iterable, right? And I is my iterator, so I assumes all the values from 0 to 9 because indexing starts from 0. Now what I have to do is I have to add sum of list equals sum of list, that means the current value plus n and I. So this is how we access the elements of the list. This is another important thing, like we will talk about how exactly we can add more elements to the list, but this is how I can access the elements of the list. Now let's do one thing. Let me just print sum of list, right? Let's just save this. Let me exit out of it. Now let me try to run this. So this is my video 11 and add elements.py. Cool. So as we can see that it has printed the sum of all the elements present in the list. So this is how this is one of the ways of doing it. But also there are certain functions which are provided by Python which we can use. We will talk about those functions. Now we have seen that how exactly we can access the elements of the list. Let's say you want to add some elements to this list. Let's say a list is given to you. Let's just open the interpreter. Now I'm just copying this list only, right? Now let's say I want to add 5 more numbers to this. What I can do is I can do the append function. So what I can do, I can append 11. So now if I look at my list, so 11 has been added to the list. There is one more function which I can use. It's called as insert, but for this I have to also provide the index where I want to insert some value. Let's say I want to insert on index number 0 and a value of 12. Now if I look at my list, it shows 12 here, right? And Python also provides a function sum. If I pass my list to the sum function, what I can get is I can get the sum. So I don't have to use this for loop because there are some utility functions which are provided by Python. Now how can you see a list of all those utility functions which are available in context of the list? It's very simple. You just have to type dir, then you have to pass in the list, and you can see all these functions are available on the list. You can see that we have sort, then we have reverse, remove. Obviously in order if we have to remove something out of the list, we can use this remove function, pop, then insert, then index, extend, count, copy, clear, and so on. So let us just explore some of these functions. I have my list n. So currently as you can see that this is not sorted. So because 12 is coming before 1, this is not sorted. If I call n.sort, now I can see that yes, 12 now is at its right place. So this is called as in place sorting. If I have to sort my list, I can use this built-in sort function. Now let's do a reverse. So let's say if I do n.reverse, and I can see that it has been reversed. Similarly, I can remove something out of the list and I can pop something out of the list. Let's understand the difference between remove and pop. Let's say if I do n.remove, let me just, yeah, as you can see that this is a built-in function method, remove of this, right? So if I do n.remove, let's see what happens. I would say n.remove 0. So it says that the element is not present in the list. So I mean, because 0 is not present inside of this list. Now if we say n.remove and then I say 1, and now I print n, now you can see that 1 has been removed. Similarly, let's do one more removal. Let's say n.remove 9. Now if I print n, you guys can see that n, like this 9 has also been removed from the list. Now let's talk about pop. So this is my list. Let me just do n.sort so that it's like in a sorted fashion. Now we can see that we have 2, 3, 4, 5, 6, 7, 8, 9 is missing because we removed it, and then 10, 11, 12. Now let's perform n.pop. Now you can see when we did n.pop, the last element, that is 12, it came out. Now if I do it again, that is n.pop, now the 11th element, which was the last element, it came out of the list. Let's try one more thing. What if I pass a 0, that is n.pop 0, then what happens? Then the 2 comes out, which means that if you call pop without any arguments, without passing any value to the pop function, then you will get the last element of the list. If you pass this index, that is if you pass n.pop 0, then you will get the very first element out of the list. Let's try one more thing. What happens if you do n.pop? Let's say, first of all, let me print n. What exactly is the current value of n? It's 3, 4, 5, 6, 7, 8 and 10, right? Now let's try a n.pop and let's try to give it some index. So let's say this is 0, 1, 2, and let's just give 2 as the index. Now you can see that it has popped the element present on that specific index. So now you are aware of 2 functions which can be used to take elements out of the list. One is the remove. Remove is where you have to provide the value which you want to take out of the list, whereas in case of pop, you have to provide the index of the element which you want to take out of the list. Cool. Let's explore some more methods. So extend is another interesting function which I would like to talk about, and let's see what exactly is it used for. So currently I have n. Let's say I had one more list which is my m, and it has values like minus 200, minus 300, and then minus 400, right? So now I have n and then I have m. Now let's see what happens if I do n.extend and I pass m to it. Now as you can see that n.extend m basically gets all the elements from the list m and appends those it does append all those elements to my original list, that is n. So now n has been extended. If I look at m still remains the same, right? So yeah, let's do a dir again on my list. There are other methods like append, we have already seen. Now clear is like as you might have guessed already, if I call clear on my list, then what happens is all my list is gone. So the list has been cleared. So in this way, like whenever you are confused about what is available, you can always check by using dir n, and you will be able to refer to these functions. So you don't have to memorize these, but all that you should know is that you just have to type in dir function, pass in the list, and you will be able to refer to these functions, right? And if you ever need more details, you can always go to the Python docs and you can explore more details about what exactly your use case is, depending on what problem you're trying to solve. So yeah, I think that's it for this video. Like we explored, let me summarize this video. So we explored the first data container, the simplistic one, that is a list. We saw how exactly we can initialize a list in Python, how exactly we can access elements, how exactly we can add more elements to the list. And other than that, we saw some functions which allow us to perform certain operations on a list in Python. So I really hope you learned about list, you enjoyed learning about list, and I hope to see you in the next videos. Thanks a lot for watching. Bye-bye.